Hey there, it's Mr. Hayes from Mr. Hayes' World of Math. I am here to help you prepare for the AP Stats exam. We're going through probability problems. That is in Unit 4 of the CED for AP Stats. And we are going to look at question number 3 from the 2021 free response question. This whole packet, including multiple choice, are linked down below. You can find it under the 3-week review. That's totally free. While you're down there, like, comment, and see what you need some help with, and see what we can come up with. And then obviously also subscribe so you can see the rest of these. I have a bunch of the older problems from the rest of this, but we're going to try to get through some of the more recent ones for you this year. This problem, to increase morale among employees, the company began a program in which one employee is randomly selected every week to receive a gift card. Each of the company's 200 employees are equally likely to be selected. So that means that P is 1 out of 200. I'm going to make that note. And the same employee could be selected more than once. That's nice. So that means that this is going to be independent. Each week's selection is independent. Oh, I already got that there. So considering the probability that the particular employee receives at least one gift card in the 52 weeks. So define the random variable and state how the random variable is distributed. I'm not sure where the rest of these are. I thought I had most of that taken off. Anyway, basically what we've already said. X is the number of wins in 52 weeks for a given employee. Probability is 0.005, and my binomial distribution. Why is it binomial? Because you only have two choices. Did you win or did you not win? We have the independent for bin, so that's BI. N is a fixed number of trials because we have 52 weeks, and it's the same probability from week to week because you can always win more than once. So it fits all parts of BI and S bins. As always, slow down. You can change the speed down in the little settings bar. Pause it as you need to. Yell at the screen as you need to. All of that will be fine. Determine the probability that a particular employee receives at least one gift card in a 52-week year. So we want to know what's the probability that X is going to be bigger than 1. So that's going to be the same thing as 1 minus the probability that you don't win anything. Because if you don't win anything, the only other option is that you've won something at least once. So remember, the probability of X plus the probability of not X is always going to equal 1. And just use that to your success. So in this case here, we have a probability of winning. How did we get that? Well, there's your probability of not winning. If your probability of winning is this, the probability of not winning is going to be everything else. So that's where I got that number. That goes here. So the probability of not winning something is going to be 0.995 raised to the 52nd power. When I subtract that, you're going to end up with about a 23% chance, 0.2295 chance that you win at least one prize over the course of a year. Last little bit. B, calculate and interpret the expected value for the number of gift cards can win. Okay, expected value, remember, is equal to the probability times the number of items. So your probability of winning is 0.005. Number of items that you have, the number of chances we're going through stuff is 52. So when I multiply that out, on the average employee is going to win a quarter of a gift card, which means that basically 1 in 4 people will end up winning stuff, which if you look back over here makes some sense because if you have this is about 1 in 4, about 25%. So that seems to be accurate for that. And then last but not least, suppose Agatha, employee at the company, never receives a gift card. Based on her experience, does she have a strong argument the selection process is not truly random? For it to not be truly random, you have to see what the probability of not winning for 52 weeks is. When I do that, the probability of not winning for 52 weeks, we actually kind of found it on the previous page. Probability of not winning for 52 weeks, you have a almost 75% chance. So 3/4 of the people will not win anything over the course of that time. So because of that, you're going to say, Agatha does not have a strong argument as the probability is at 0.7705. We eventually find out that obviously it has to be under 5% for that, but so we are definitely far away from that. And that's it. You just got yourself 4 points on a probability problem. That really wasn't so bad, hopefully. Up over here, I've got the rest of the probability problems that we're doing. Up above here, we're going to do all the stuff from CED 5, and we'll see you soon.